It's Mr. Loftus, and these are the notes for how to convert different forms of linear equations to slope-intercept form. And these notes are only going to show how we started the Explorer on the bottom of page 112. There'll be more notes on how to do this. There'll be another video on this section on different forms of linear equations. But what we did in class was read the directions for this Explorer, and the directions basically said that the four equations that are listed have really only two equations. One is different than the other three, and the other three match up. So what we did was we made an XY chart for each of the four equations. So starting with the equation y plus 10 equals 3 times parentheses x plus 2, we put the two values of x equals 0 and x equals negative 2 to see what our y values would be. And then we just want to match these tables up with the other equations. So this is how we found the value of y when x was equal to 0. It turns out that y is equal to negative 4 when we simplify it and then solve this one-step equation. So y was equal to negative 4. And now we're going to replace x with the value of negative 2. So we're going to take that 0 out and put in negative 2 and see what the value of y is. What we're doing is finding 2 points on a line. So we found that when we put negative 2 in, that resulted in a 0. So y plus 10 is equal to 0. If we subtract 10 from both sides, 0 minus 10 is negative 10. So when x is equal to negative 2, y is equal to negative 10. So we're going to keep that table up, and now we're going to do the next equation. Y equals 1 plus 3 times parentheses x plus 1. And I'm going to kind of skip forward here a little bit. We're going to put the same values of x equals 0 and x equals negative 2. So we have two things to do for each table. Here's the first one. When we put in x equals 0, we got a value of 4. When we put in x equals negative 2, we got a value of negative 2. So you can see that this equation is not the same as this equation. They don't have sharing points at x equals 0 and x equals negative 2. They're at different places. So now we're interested in this third equation, negative 9x plus 3y equals negative 12. It must match up with one of these. So we already know if we put in the values x equals 0 and x equals negative 2, it's going to match one of the other equations. So we'll start with x equals 0. And again, I'm going to speed this up a little bit. So y equals negative 4. And so this matches with the first equation. So these two equations, the first one and the third one, match up. So we'd expect that when we put in negative 2, then we would get a negative 10. And in fact, that's what we get. Now, when we do the third one, we really are just confirming that the third equation is going to match the first and the third. These already match, so those are the matching ones. So I'll go pretty quickly. We'll put in the value of 0 and -2, and we do in fact get -4 when we put in 0, and we get -10 when we put in -2. So we can just put a line through this one. It doesn't match the other three equations. The other three equations are really in disguise the same exact equation. Y plus 10 times 3 parentheses x plus 2 is a different form of -9x plus 3y equals -12, and it also is the same exact line as 6x minus 2y equals 8. Now, just looking at them, we couldn't match them up, and what we're going to do is come up with some shortcuts to match them up so we don't have to make these tables.